Hi guys, and welcome to the channel. In today's video, we'll be talking about the insane engineering of SpaceX Raptor engines. Without further ado, let's begin. SpaceX CEO Elon Musk has his mind set on going to Mars. To do so will require a vast new spacecraft, powered by a new rocket engine unlike anything that's been seen before. Step Forward Raptor, the future of SpaceX's endeavors. Raptor is a family of full-flow staged combustion cycle rocket engines developed and manufactured by SpaceX for use on the in-development Starship fully reusable launch vehicle. SpaceX's new Raptor engine is a methane-fueled, full-flow staged combustion cycle engine, and it's so hard to develop, no engine like this has ever flown before. The Raptor engine is more than twice the thrust of SpaceX's Merlin engine that powers their current Falcon 9 and Falcon Heavy launch vehicles. Raptor is intended to be used in both stages of the two-stage-to-orbit Super Heavy Lift Starship system launch vehicle, which will supersede the Falcon 9 and Falcon Heavy. Raptor is designed to power the new reusable vehicles SpaceX is building, the Starship spacecraft and the Super Heavy rocket. Combined, these vast machines are designed to take up to 100 people into space, possibly to the Moon and Mars, with a tentative launch of humans around the Moon planned in 2023. SpaceX tested the first flight-ready version of Raptor in February 2019, and last week it flew a Raptor for the first time on a hop test of a prototype of Starship called Starhopper. The engine has been in development for the better part of a decade, going through a number of iterations. At its core, it's like other engines, burning chemical fuel to produce thrust. But its use of liquid oxygen and methane, something largely unprecedented in the rocket industry, and its innovative design means that it just might be SpaceX's ace in the hole when it comes to exploring the solar system. There is no other rocket engine capable of producing as much energy out of liquid methane and liquid oxygen as the Raptor engine, says Tim Dodd, an industry expert who runs the popular Everyday Astronaut YouTube channel. And making it more reusable with little to no refurbishment is the idea. That's definitely going to help their business case if they can just fly over and over. The reusability is a key aspect, as Musk has said each engine needs to be capable of flying up to 1,000 times to support the ambitious operations of Starship. That's a major challenge. The most reused engines in space exploration history were the main engines on each space shuttle, which flew up to only a few dozen times each. It's quite ambitious, says Dodd. I don't know if 1,000 flights is necessarily going to be achieved in the near future. If it lives up to its potential, maybe 1,000 is within the realm of possibility one day. SpaceX's existing engine is called Merlin, which is used on its operational Falcon 9 and Falcon Heavy rockets, but Raptor heralds a significant improvement. One is that it has double the thrust of its predecessor thanks to a much higher pressure, 380,000 pounds of thrust at sea level versus 190,000 pounds despite being a similar size. If you're enjoying the video, then hit the like button and smash the subscribe button. Raptor also uses what's known as a full-flow staged combustion engine, only the third engine in history to employ this technique, whereas Merlin uses the more common open cycle system. The previous two attempts at such an engine, one in the Soviet Union in the mid-1960s and another in the US in the early 2000s, never made it beyond testing. A full-flow staged combustion engine refers to how a pump spins a turbine to drive the engine, using what's called a pre-burner to get this process going by injecting a small amount of fuel. Normally, some of the propellant is expended in a traditional open-cycle engine to start this process, but Raptor will use every drop of propellant available, making it one of the most efficient rocket engines ever built. Rockets are basically just propellant with some skin around it to keep it in place, and they have a thing on the back that can throw said propellant really, really fast. The easiest way to do this is by storing all the propellant in your tanks under really high pressure. Then, put a valve on one end of the tank and a propelling nozzle that accelerates the propellant into workable thrust. SpaceX developed their own superalloy in-house that they named SX500. Raptor burns that fuel at a high enough pressure that can then steer the fire from pre-burner back into the combustion chamber and completely burn that propellant with the rest of the propellants, says space consultant Charlie Garcia from the Massachusetts Institute of Technology, MIT. And it does this in a very clever way that only the Russians have done previously, by putting all the propellant in the engine through the pre-burners. The end result is that Raptor has a much higher pressure than Merlin, about 3 times greater, making it the highest pressure rocket engine in existence and leading to its aforementioned larger thrust than Merlin despite its similar size. In 2016, Musk referred to the insane pressure inside the main chamber of the engine, 300 bars, which required the development of a new metal alloy. Of course, Raptor's other major innovation over its predecessor is the use of methane, which harkens back to SpaceX's ultimate goal. SpaceX isn't the only company moving to methane, as rival firm Blue Origin, headed by Amazon CEO Jeff Bezos, is also developing its own methane engine called the Blue Engine 4, BE4. With numerous benefits, it's a switch that almost seems long overdue. According to Elon, it's capable of over 800 bars of hot oxygen-rich gas. That may have been one of the biggest hurdles in developing the Raptor engine. In the 60s, the Soviets developed an engine called the RD-270, which never flew. And in the early 2000s, Aerojet and Rocketdyne worked on an integrated powerhead demonstrator called the Integrated Powerhead Demonstrator, which again, never made it past the test stand. And the third attempt at developing a full-flow staged combustion cycle engine is SpaceX's Raptor engine. That's right, the Raptor engine is only the third attempt at making this crazy type of engine. It's the first to ever do any work and leave the test stand. And fingers crossed, it'll be the first full-flow staged combustion cycle engine to reach orbit too. Well, actually, just about everything this engine does will be a first. But all this means SpaceX had to tackle many very difficult problems. Not only did they need to solve the same problems with an oxygen-rich cycle, they also had to precisely control fuel to create the highest chamber pressure of any rocket engine ever at 270 bar, finally beating the RD-180's record of around 265 bar. Most previous rocket engines have relied on using fuels like kerosene in place of methane. But the main benefit of using methane is that it has a higher performance than other fuels, meaning the rocket can be smaller. Its lower cost too means the total cost of launching can be brought down. This could be crucial because the number of Raptor engines SpaceX is looking to build is immense, to say the least. Each Starship vehicle is designed to fly with 6 Raptor engines, along with 35 on the Super Heavy rocket, a total of 41 per launch. SpaceX's biggest rocket so far, the Falcon Heavy, launches with 28 Merlin engines, 27 on the bottom and 1 on the upper stage. With the number of launches SpaceX is planning for Starship and Super Heavy, their rate of production will need to increase significantly. It's also believed that methane could be available on the surface of Mars or elsewhere in space to be used as fuel, perhaps by mining water and carbon dioxide, known as in situ resource utilization, ISRU. So guys, let me know in the comments section below, what do you think about the SpaceX Raptor engine? For more interesting content, give this video a thumbs up and don't forget to subscribe to the channel for more awesome content. Have a nice day, and I'll see you on the next video.